So you want to do the characteristics of polynomial functions. As you see in this picture, this is polynomial, graph of the polynomial. We have a local maximum point. So this point is highest point with respect to the neighboring point. And this point is a local minimum. Again, this is a lowest point compared to local or neighboring points. Now, finite difference. For finite difference, I want to give you an example. Let's say y is equal to x power 2 minus 1. I'm going to give a bunch of data here for you to understand it better. The finite difference. Let's say we have x, we have y. I'm going to start with -2. Negative to the power 2 is 4, minus 1 is 3. -1. So -1 power 2 is 1, so 0. 0. If you put 0 here, you get -1. Okay, let's put that here. You put 1, 1 power 2 minus 1 is 0. 2 power 2, 4 minus 1 is 3. I'm gonna give you another point. 3 power 2 is 9, minus 1 is 8. Now, I'm gonna take the first difference. First difference. So what is the first difference? If I say first difference, means you take these y values and minus it from each other. So 0 minus 3, right? 0 minus 3 is -2. -1 minus 0 is -1. 0 minus -1 is +1. 3 minus 0 is 3. 8 minus 3 is 5. As you see, we get a different bunch of numbers. Now I'm gonna do the second difference. So second difference. For second difference, -1 minus -2, it will be 1. 1 minus -1 is 2. 3 minus 1 is 2. Oh guys, 0 minus 3 is -3. I have to correct that. This one, 0 minus 3 is what? It's -3. Let me just correct this one. Here is -3. Now we're correcting that. -1 minus 3 gonna be 2 here. Okay. So -1 minus 3, -1 minus -3, because you have to subtract them, is 2. 1 minus -1 is 2. 3 minus 1 is 2. 5 minus 3 is 2. As you see, we have a same number for second difference. Because the power is 2, our second difference will be constant. Make sure the degree here, we have degree 2. That's why second difference is constant. Okay, there is a relationship between the leading coefficient and this nth difference. So I'm going to put that. So leading coefficient equal to nth difference divided by n factorial. Now, the general form for any polynomial, as we did before, is equal to what? Ax power n, right? An x power n equal plus an minus 1 x power n minus 1 plus dot dot plus the last term is ax a1 x1 plus a0. So this is the constant. So here the leading coefficient is an, right? So instead of that I can put an, the leading coefficient. Nth difference, when the degree is n, my nth difference gonna be constant. And factorial is the degree here. Now, according to this one, I wanted to find, let's say I have the same thing. Y is equal to x power 2 minus 1, right? So I want to find nth difference, let's say. What I do, the leading coefficient is here is 1. So I know a because this degree 2 is a2, right? Is equal to second difference because the degree is, the n is 2, right? Second difference divided by n, the highest power is 2 factorial, right? Here I know the leading coefficient here is 1, so 1 is equal to second difference divided by what? 2 factorial. If I rearrange it, second difference equal to crisscross 2 factorial to the other side. So 2 factorial multiplied by 1. I know 2 factorial, just making notes here. 2 factorial is 2 multiplied by 1. If you have 3 factorial, it's 3 multiplied by 2 multiplied by 1. 4 factorial is 4 multiplied by 3 multiplied by 2 multiplied by 1. This is the meaning of the factorial. For 1 factorial is just 1. Make sure you understand 0 factorial is exceptions. Don't say this is 0. This 0 factorial, remember this is 1. This is exceptions. Anyway, 2 factorial is 2 multiplied by 1, and here is 1. So the answer is 2. See, my second difference here is 2. I got that right. So let's say sometimes you do not have leading coefficient. You have nth difference and n factorial. So you want to find leading coefficient. You can use this formula. Okay, so let's just move on. This is another question. Let's say this data is given to you, x and y, and you want to see what is the degree. The question is that, what is the degree, sign of leading coefficient, and value of the leading coefficient. First things we do, we find first difference. Negative 12 minus 36 is 24. Negative 2 minus 12 is 10. 0 minus 2 is 2. 0 minus 0 is 0. And so on, we continue. As you see, these numbers are not the same. We have to do the second difference. So 10 minus 24 is negative 14. 2 minus 10 is negative 8. 0 minus 2 is negative 2. We continue to get all of that. See, these numbers are not the same, so we have to go to the third difference. Negative 8 minus 14 is 6. Negative 2 minus 8 is 6. We continue. We see all of that is the same. So third difference is constant, or the same, right? So the degree here gonna be what? 6. Sorry, the degree gonna be 3. This is nth difference. This is third difference. Third difference. I got third this difference to be 6, right? And what's the n? Of course, if the third difference is constant, means the degree is 3, means the n is 3. Okay, knowing the equation that a of 3, the leading coefficient, is equal to third difference divided by n factorial. I know n is 3, so 3 factorial. If you want to find a3, you just say third difference is 6 divided by 3 factorial. So 6 divided by 3 factorial is 3 multiplied by 2 multiplied by 1, which is 6 divided by 6 is 1. So this is my leading coefficient is equal to 1. Leading coefficient is positive. See, the leading coefficient and the third difference, they have the same sign. If the third difference is positive, then the leading coefficient is going to be positive. Okay, so this is more information. You can look at that. Key features of the graph of polynomial function. Just remember that we did those parent function for y is equal to x. You know, guys, that was like that. For y is equal to x power 3, it was like this, right? Y equal to x power 5, that would be the same as x power 2. So as you see, we have the nth behavior when the leading coefficient is positive. So the power here is what? This is odd. The degree is odd. Here is 135. The degree is 135 is odd. If the leading coefficient is positive, so here's leading coefficient for all of this are positive. But the end gonna start from quadrant 3 to the quadrant 1. See, from quadrant 3 to the quadrant 1. From quadrant 3 to quadrant 1. Since this graph is a start from quadrant 3 and end quadrant 1, I can say that we have a positive leading coefficient, and this is odd. The power or the degree is odd. The same way I can show, knowing y is equal to negative x, everyone know the graph is look like that. Y is equal to negative x power 3. The graph is look like this. And y is equal to x negative x power 5. The graph look like that. Again, the power is odd. The leading coefficient is negative. The end behavior is quadrant 2 to quadrant 4. Quadrant 2 to quadrant 4. Quadrant 2 to quadrant 4. Same thing for this one. I can't, because starting point is quadrant 2, ending is quadrant 4. I can say that the leading coefficient is negative, and I have odd. The degree is odd, right? This one, you also know when the y is equal to x power 2, the leading coefficient is positive, the power is even. You know that the shape. Also for y is equal to positive x power 4, the shape is this again, but is narrower, it's growing faster. So as you see, it is a start quadrant 2 to 1, quadrant 2 to 1. If your degree is even degree, and the leading coefficient is positive, so you're starting from quadrant 2 and end gonna be in quadrant 1. See, this picture is even degree and positive leading coefficient. The same way we can say that about this. You know y is equal to negative x power 2. It's look like that. And y is equal to negative x power 4. Again, it's look like the same, but is narrower. So the end behavior gonna be starting from quadrant 3 to 4. 3 to 4. In this picture, because it is the end at quadrant 3 and 4, we say that the leading coefficient is negative and degree is even. So from the end behavior, I can predict if the leading coefficient is positive and negative. Also, I can find the degree is even or odd. That's the information I can get from that. So the next thing is predicting what is the, from the zeros, you want to see predict the degree. See here, this, how many zeros do we have? Here is 1, 2, 3, 4, right? And remember, when you have y is equal to x, see, y is equal to x. What is the power of the x here is 1. So here we have a 0, that this one just passed through, right? Passing. If you have a 0 or x-intercept that your graph is passed through that 0, the degree of that 0 going to be 1, like that. This is passing, right? So the degree here is 1. Here is again pass. Degree is 1. It's passed through x-axis. The degree is 1. Passed through the axis, degree 1. Addition of all of this, how many of them? 1, 2, 3, 4, 4. So the degree gonna be, you have degree 4 here. Look at that. All of this 0 is passed through, right? So the degree of each is 1, 1, 1, 1, 1, 1, 1. How many of them? 1, 2, 3, 4, 5, 6, 7. So the degree gonna be 7. Okay. Just do the next one. Look at that. I have one of the zeros is passed through, but this is turning. How should I deal with that? Again, I know when the x is, the degree of the 0 is 1, means you just pass through it. But if the degree is 2, like x power 2, right? Yeah, the zeros or x-intercept is turning. So this is double 0. That's why we count it like as 1 because it's passed through. Now it's turning is like x power 2. We count it twice. So 1 plus 2, 1 plus 2 is 3. So the degree is the lowest degree we can do that. So because it's turning, it could be power 4, right? Because the power 4 is turning as well. But I'm just considering the lowest one. The same thing here is turning, and here is turning. My 0 is turn here, turning. So the degree here is 2, 2. 2 plus 2 is 4. The degree here gonna be 4. This one. See again is turning. So I count this one twice as degree 2. Here is pass through, so the degree 1 here is pass through the degree 1. 2 plus 1 is 4. So the lowest degree is 4. It could be more. I could count it as 4, and here is 1 and 1, and then add up to 6. But I wanna do it to be like a 4. Consider that one as to be degree 2. How about this one? See, this is concave up, concave down. Do you remember that we said y is equal to x power 3? What was the shape of that? The concavity is changing around this. See, it's passing, but the concavity is changing. That's why this look like the x power 3. So we count it as a tree, degree 3 here, and here is past 3 is degree 1. So 3 plus 1, 3 plus 1 is 4. Again, this is the lowest one. I could count it as 5 and say 5 plus 1 is 6. But I want to look for the lowest possible degree to predict that.